Hello, this is Mike Lively from Northern Kentucky University, and this is the second video of 2 on Papervision3D Pendulums. It's a free NKU Seminar, number 3, and if you want to get all this information, you can go to the blog post at www.professionalpapervision.wordpress.com. In addition, all the resource files are downloadable, and those are on my Google Code site, so let's scroll down here a little bit. And if you click on source files, it'll take you to Google Code. And if you click on source files, it'll immediately download the Pendulum zip for you. You can unzip that and place it into Flex and begin working along the project. Okay, let's move down and start again with the next pendulum, which is the torsion pendulum. Now, I really like this pendulum a lot for some reason. It's just basically a rod spinning on a spring. But what we learn in this part is how to add sliders and actually create some interactivity. Now, you've already seen some sliders, but it's really sliders that add the thrill of interaction to your system. And so basically it's very simple to add a slider in Flex. Now, you've got to make a decision when you work with these 3D systems. Am I going to use the UI components from Flex or Flash because they don't mix, or create custom UI components? But since Flex is free for educators, it's just a logical choice to choose the Flex components, and we'll do that right now. And it's very simple. We just put a slider on the stage, and all you have to do is go to Flex and just from the components library, just drag a slider around the stage, and this code right here is generated for you automatically. And all you have to do now is basically here is a change function. So you need to create that change function, and let's see what it looks like. There it is right there. It's a slider change function, and basically what happens is whenever the slider changes, it creates a variable, and you fill that variable my SP constant with whatever the slide value is. And then that slide value is sucked up in the oscillation equation. Here's the oscillation equation for the spinner right here, and basically the torsion and the simple pendulum have the same solution. Let's take a look at that simulation. Let's click on it. And I'm going to reinitialize that, get a different color of the string. And here's my oscillating rod. And here's the torsion equations. And basically here's the equation for the acceleration of angle. And here's the spring constant. And when you change this, you actually increase the spring constant. When I did that, you can see I'm oscillating more rapidly. Or I can bring the spring constant down, and I'll oscillate more slowly. And in this case, we see that the frequency is proportional to the square root of the spring constant. Let's move on to the next pendulum. So we kind of hope we've saved the best for last here is the Foku pendulum, which uses the environmental map. And we actually want to get more of a realistic look on this pendulum and show you more of the 3D. The other ones looked like they were 2D, but they were actually 3D. Here you'll actually see the 3D behavior. And we're going to create a Foku pendulum with a realistic environmental map on it, and it's going to actually draw its path on the lower plane. So a very cute animation, important here. It's pretty much easy to do. I want to mention a very important blog here. Jim Foley has a blog called Mad Vertices, and he just does a super job on teaching you how to use primitives and put textures on them and use shaders such as the environmental map. So you want to visit that blog, Mad Vertices. It's just click on the link right here and go there. Pretty much we took our environmental mapping from his demos, and I can't just rave about it enough. There's code, video, and demos, so go there, check it out. We'll be doing more examples with these particular materials, but that's always a good place to start. So all you really need to do is just create a material and bring out the environmental map and add a light to it, an environmental map, and a color. And we did that. And let me show you that example. So here's the pendulum oscillating in 3D space. And now you can actually see that beautiful oscillation I told you about. And it's drawing its curve. Now let me come along here and just say a few things. Basically, the way this goes is that there's a competition between Coriolis force. And on different places on the Earth, there's more Coriolis force than others. On top, there's the maximum. In the middle, there's no. In the bottom, there's the opposite direction. So we have these equations here that we're working with. and it's pretty much fairly a linear approximation again. But this phi here actually is that latitude angle. And so you can see if you reverse the latitude angle completely, the pendulum actually changes its direction, which you expect because the Coriolis force is reversed. I'll bring that down. And so I'm going to play along here with this little bit of slider here. And so now let's slide to the other direction. And all the way to the other end, you should see the pendulum, yes, indeed, changes direction. That makes me pretty happy. And if you go toward the equator, okay, we're going to zip along to the equator, which is 0 degrees here. You should basically have no oscillation in the circular direction there, and you don't. See, it's just oscillating back and forth. So this was really a beautiful example. It worked really well. We're really happy with this one, and it looks good too. So it's always great when something looks good, and that's the focal pendulum. So in this tutorial, we actually covered 4 pendulums: the simple pendulum, the double pendulum, the torsion pendulum, and the focal pendulum, and they're very great examples. We use sliders so you can interact with them. There's a lot more that can be done with these examples, but what we found out, which was amazing, that through using encapsulation, it was actually easy to do. And so we plan to make a lot more of these simulations and experiments in the future. We want to wrap this up with an example of a pendulum use. You know, they're not just for oscillation of a single string and ball, but you can actually use it for other things like a butterfly. And on Seb Delai's blog, which is a great blog, definitely should visit that. There is an example of a butterfly. Let's take a look at it. So Seb has this wonderful butterfly that's on a reflective plane, basically flapping its wings back and forth in a sinusoidal motion. So there you go. There's your simple pendulum. So let's take a look at the code. So we're back on the blog. We're going to take a look at the code real quick and how this was created. He had a left wing and a right wing and created a butterfly display object and pretty much declared those as left and right wing. And he created a butterfly wing material that was double-sided, and once again put those materials in a plane, and he shifted the planes around so they matched, and he added those wings into a butterfly display object. And then what he did was he placed a sinusoidal oscillation on those wings from a timer, just like the pendulum. Now the two things that could be used to really enhance this would be to add pinning and encapsulation. This was not an example of encapsulation, but once you do that, you can actually fly this butterfly all over the screen. And that's some of the applications you'll be seeing in the future. This is Mike Lively from Northern Kentucky University. Hey, thanks a lot for tuning in, and we got some cool stuff coming down the line. So best regards. Hope you like the seminar.